Today's video is based off of one of my non-maths hobbies. It's a Dutch sport called Korfball. This problem here is actually taken, I've just reworded it from a PUTNAM problem from 2004. We have Korfball star J-Pi keeps track of the number, SN, of successful free passes he makes in the first N attempts of the season. So a free pass, well, I'll have a clip of it on screen as to what it is. Let's continue with the problem though. Early in the season, SN was less than 80% of N. But by the end of the season, SN was more than 80% of N. Was there necessarily a moment in between when SN was exactly 80% of N? So at one point it's less than 80% of N, at one point it's more than 80% of N. Must there have been a time where it was exactly 80%? Do have a go at this problem, but I'm going to dive right into a solution. The answer, in fact, is yes, there must have been. And the way we're going to prove that is by contradiction. So we're going to suppose that there wasn't a point where SN was exactly 80%, which means if that's the case, there must have been a point where SN was less than 80%, because at the start of the season it was less than 80%. And then I make a free pass, and that causes my percentage, this conversion rate to go above 80%. So let's say that that happens at some time N. So we can say that, so if I score the n plus 1th goal, so the n plus 1th goal or free pass causes I guess n plus 1 to be less than 80%, but or divided by n plus 1, and s of n divided by n was less than 80%. Okay, cool. And we're going to show that this leads to some sort of contradiction. Okay, let's take this first. When we get the s of n over n is less than 80%, which is 4/5. And so that just means that 5s of n is less than 4n. Okay, cool. Let's take this second inequality. So this says Sn plus 1 over n plus 1 is bigger than 80%. But if I'm scoring my n plus 1 free pass, then that means that Sn plus 1, the number of successful free passes, must be equal to Sn plus 1. So this inequality here is the same as Sn plus 1 divided by n plus 1 is bigger than 80%, which is 4/5. And so if I cross multiply, I get 5 lots of Sn plus 5 is bigger than 4n plus 4. And if I just minus 4 on both sides, I get 5Sn, Sn, let me write that again, 5Sn plus 1 is bigger than 4n. But from this inequality here, we get 4n is bigger than 5Sn. But hold on a minute. All of these terms are supposed to be integers, but these guys here are consecutive. 5Sn plus 1 and 5Sn are consecutive integers. But 4n is supposed to be an integer, and there's no way you can have an integer sandwiched between two consecutive integers, and thus we arrive at a contradiction. Hence, there must have been a point where I had scored exactly 80% of the free passes I had taken.